Always, if you do it yourself, then you don't have to, read it again. Once you do it by yourself, then you will be more comfortable handling it. All right. So now, as I already mentioned, if there are no questions from the participants, the session is dedicated to discuss certain questions at the green belt level, particularly analytical questions, right? If there are numbers involved in the question, how to handle it, and so that you can find out the best answer that are there in the question, right? So now read the question and let me know whether you can handle it, right? The mean and standard deviation of the data set is given to you. You just have to find out, right? The data is given. You just have to find out the mean and standard deviation. Tell me, all of you are able to handle it?
Yes, sir.
How will you do it? In Excel also you can do it. In Minitab also you can do it. In Excel, how will you do it? All of you know, right? RK sir has given a template.
Yeah.
You just have to copy paste the data and it will immediately throw mean and standard deviation. Otherwise, what is the formula for the calculating mean and standard deviation? Average,
Mean is-
right?
Yeah, average.
To calculate the mean, the formula is average. And for standard deviation, STDEV dot S, sample standard deviation, right? And all that required is you just have to type it in the Excel and then calculate the mean and standard deviation. Otherwise, you can go to Minitab and then you can calculate what you call the descriptive statistics, right?
This video will also be provided.
Which one?
This class, like we
Recording,
didn't get the last that you have discussed on Wednesday or Thursday.
That I already posted. Already, that's why I shared the YouTube channel link also. You can stay subscribed.
Yeah, I went
As
through
and,
it.
as and when I post it, you come to know. Similarly, this probably tomorrow morning you will get it.
Okay. On
Alright.
YouTube, like.
Yeah, that will come in directly YouTube.
Okay.
So see, this is very simple. Either you can calculate manually, you add all the data, and then how many are here? 2, 4, 6, 8, 10 data are there. Add all the data and divide by 10, you get the mean. Right? And then standard deviation, doing it manually, little tough task, better to you type it in the Excel and then get it in the Excel. All of you will be able to do it. How to do it in the Excel? Or should I show you that also?
Yeah, we'll do it.
You all will do it, no? All right.
Yeah.
So those who know, you can educate others. So I'm moving on to the next question. So what is the area contained within plus or minus 3 standard deviation from
99.73
in the normal curve? All of you are clear? 99.73?
Yes, sir.
What are those points called? 3 sigma points from the center.
Yeah. -1 to +1, -2 to +2, and plus minus 3.
That is correct. What is the name of the point called? Which is 3 sigma from the center. What is that point called?
Okay.
Control limits. Process control.
Control limits, process control limits. On the right side, it is upper control limit. On the left side, it is lower control limit. Suppose instead of plus or minus 3 sigma, when I put plus or minus 2 standard deviation, then the answer will be 95.4.
95.4.
95.
These points are called warning limits. These points are called warning limits. Right? So relevant question will come, and that is what I'm explaining. Suppose if it is plus or minus 1 standard deviation, which is the best answer? Sometimes correct answer may not be there. If correct answer is not there, you have to go for the best answer.
68%.
68%. The correct answer is 68.27. All right. So we move on to the next question. Welcome, Arogiraj. Very good. Now, which is the formula, correct formula for DPMO? DPMO means defects per million
opportunity.
So what is the formula DPMO? DPO into 1 million. DPO is defects per opportunity. 1 million is 10 power 6. Can you see 6 zeros here?
Yeah.
Remember the GEMS experiment we did, right? Remember the GEMS experiment we did? You know opportunity, you know defects, you know defects per opportunity. You should also know defects per million opportunity. Sometimes you may require defects per unit, right? And all these things, whichever they ask, but this is the formula. Hope this is, easy to understand. Am I right?
Yes, sir.
Yes.
Yeah. Now all of you can now pick up your Excel sheet, and now you can try to work out this yourself, right? The dimension of a particular part should be between 225 mm and 230 mm. So what is this 225 and 230 mm?
That is
225 is the lower limit, as well as
230.
230 is the upper limit.
Okay, when you say limit, clearly say whether it is control limit or specification limit. What is this 225?
Specification
Lower
limit.
specification. 230 is upper
Upper
specification.
specification.
An
Upper
operator
specification.
collected a sample of 100 parts. Process average is 226. Variance is 0.4. I want one of you to write down these numbers because I will be doing it directly in Excel, and you also can do it directly in the Excel. I have already shared the Excel file in corresponding WhatsApp groups, right? So please note down the number, and then I will open my Excel file. So should I stop sharing? Please note down these numbers. LSL, USL, average, variance. That's all. 4 values. Shall I stop sharing so that I can open the Excel?
Yes, sir.
Okay, I stopped it. Just give me a moment. I'll just get the Excel for myself, and all of you can get the Excel for yourself, right? Please try to do it parallelly, right? Because if you do it, you don't have to rely on any video or anything. You can rely on your understanding. That is for sure. So I'm just getting my Excel file. Sigma level calculator version 5. I'll share that also. It is opening. It got open. So I'm sharing the Excel file. Hope all of you can see my Excel file now. Please confirm. Am I right? All of you, can you see my Excel file?
Yes,
Yes,
sir.
sir.
Yeah. And now there is the discrete data situation for which everything is available, DPMO, sigma level. Now sigma level calculator. Sigma level calculator, this is for continuous data. When the LSL, USL, all these things are given. See here, there is an option here. Mean, standard deviation, LSL, USL. What is our value of lower specification? Can one of you tell me?
225.
225.
Okay.
225 is LSL. And now USL 230, yeah?
230. Yes.
230. What is the mean process average?
226.
220.
226. And I need process standard deviation. Is this process standard deviation given to you?
Variance only given.
Variance only given. If variance is given, how to get the standard deviation?
Standard deviation. Square root of variance.
Square root
Square
of
root of
100.
variance. So variance is how much? 0.4.
4.
So square root of 0.4. Look at the formula. That will give me variance. So how much is the variance? 0.6. Sorry, standard deviation is 0.632456. Oh, I'm sorry. So let me type it here. 0.632456. Now I enter. Now you can see the DPMO. You can see the sigma level LT. LT means Z LT. And you can also see sigma level ST. What is the question actually? What is the question? Sigma LT and sigma ST, right?
Sir, ST full form.
ST means short term, LT means long term. ST means short term, LT means short term. Sigma means sigma level, measure of capability. Measure of capability, right? Measure of process effectiveness. Can one of you write down the LT, ZT value so that we can go to PPT and check? Write down. Suppose if they ask DPMO, DPMO is also available here. Right? So one question we are just seeing, but then any question asked in this line, you can answer. Right? Noted? Shall we proceed? Who is noting?
Yes, sir. Yes, sir. I have noted.
Okay, thank you. Please confirm always. So now I'm just going to the PowerPoint so that we can verify our answer. Are you getting this answer?
Yes, sir. 1.58 and 3.08.
Clear? See here, the same screenshot is also mentioned. You just have to type all these things. This is how we did it, isn't it? You remember? And anybody practiced it parallelly using the Excel? Or anybody practiced it using the Excel parallelly? None of you? Come on, please respond. Are you able to do it? Or see, if that is the case, in the examination, you have to do it yourself. We won't be coming, when inside your exam hall. Exam hall only you have to perform. So, can you try it now? Just the Excel file, please open and please key in all the details and see for yourself. Is it LT and is it ST coming on? Will you do it at least? Come on, please tell me something. Can you do it? Or do you want to do it right now?
Yes, sir, we'll do it.
Later, right?
Yes.
Okay. Always you want to do it later, but see that you are doing it today itself, right? Okay. So now next question. 3,000 dishes are inspected. 60 are defective. What is the ZST? 3,000 dishes are inspected. 60 are defective. What is ZST? And now again, there is a chance you can go to the same Excel file and the first sheet, discrete data situation. All of you, do you know what is discrete data? Countable information. Do you think this is countable information? Yes or no?
Yes.
Countable information. So go to discrete data situation. Go to discrete data situation. And which situation will best fit now? Situation 1 or situation 2 or situation 3? Situation 3 will best fit. Why? Because they are talking about defectives, not defects. So look at the entry here. In the defectives box, you have to type 60 and number of samples, you have to type 3,000. Now, what is your ZST?
3.55.
Please do this right now.
Yes, sir.
1 minute task. Do this right now and confirm whether you are getting 3.55. 3.55 is the answer. Suppose if in the examination they ask you, is it LT? This will be the 2.05 will be the answer. Suppose in the exam instead of 60, they say 100, then you put 100 here. Understand? Are
Yes,
you getting it? Can somebody confirm that you are also able to get the answer using the Excel?
Yes, sir.
Nega madam, are you doing?
Yes, sir.
You got the answer?
Yes, sir. 3.52.
Very good. So we are moving on.
Yes.
Now next question. While editing orders over the phone representative must mandatorily check for 6 fields on the order form. So the company is collecting details in an application form. How many fields are there? 6 fields are there. So your name, your date of birth, your father's name, and your education qualification, your monthly income, certain detail. If you fill it wrongly, any of the information that is considered a defect. So how many opportunities are available? 6 opportunities are available. That is what you need to understand. The quality team sampled 200 calls. 200 forms. And out of the 200 forms, they found 5 defects. 200 calls. Every single call, they enter 6 fields, isn't it? So totally 200 into 6, there are about 1,200 opportunities. Out of the 1,200 opportunities, how many defects occurred? 5 defects occurred. If this is the scenario, what is the long-term sigma level? That is the question. Now, situation 1 will straight away match. Why situation 1? Again, sheet number 1, discrete data situation. Why it is situation 1? Because the opportunity for error is known. Can one of you tell me what is the opportunity for error in this case? What is the opportunity for error in this case?
6.
All right. So you have to type 6 here, OFE. And 200 for 200 is the sample size. How many defects observed? 5.
5.
If you enter
5.
these things parallelly, you can enter now, and you need to just check up the ZLT value. Please confirm whether you are getting 2.64. Just do it and then tell me that you are getting. Then we can move on. Are you getting it? These are, in my opinion, these are very simple questions
Yes, sir.
which you can definitely answer, right? Similar questions you can definitely answer. All that required is this Excel sheet, and then you need to know how to use it. And the file I gave also contains lot of data files for practice purpose. You can practice. Yes, that
Yes,
much
sir.
time is required.
Yes, we got.
But do you get it? Is that LT 2.64?
Yes, sir.
Yes, sir.
Agilan got it. Nega also got it. And others also should have got it. And now, for a process, CP equal to 0.94. CPK equal to 0.33. What is your understanding for CPC process capability? CPK should be 1.67 if it is a critical process. Nothing is mentioned. Consider that as a critical process only. If it is non-critical, requirement is 1.33.
3.
So now it is 0.94, 0.33. In both cases, it is low, which means the process is not capable. The process is not capable. That is mentioned here. Now, what action is needed? Statistically, what action is needed? Problem, see, whenever CP, CPK, both are not up to the mark, there is a problem with mean also. There is a problem with standard deviation also. How do you know whether problem is with the standard deviation or not? You know, you come to know that the problem is due to standard deviation if CP is low. You can conclude that problem is with the standard deviation when CP is low. How much
Low.
is your CP? 0.94. What is the requirement? 1.67.
7. 6, 7.
So what is the problem is with the standard deviation? Now standard deviation is higher or lower?
Lower.
Standard deviation is
Lower.
higher.
Higher.
Standard deviation is higher.
Ah,
That is,
yes,
that is why there is a problem. Variation is high. So
Yes.
the action required is reduce variation.
It's very tall.
All of you understand why I am using this word reduce variation? Because CP is lower. Why is CP gone lower? Because variation is too high.
Hmm.
You reduce the variation, that will improve your CP. Now, another observation. Look at the CPK in comparison to CP. Are they same or different? Tell me, are they same or different?
Different.
Different. That means your process is shifted. Your process is shifted. Process shifted means process center is shifted. Process center is nothing but the process mean. So move the process mean close to the target. If you move the process mean close to the target, CP and CPK will start approaching each other. And our ideal condition, CP should be equal to CPK. Hope all of you understand. So the recommendation or the action required to improve the capability is you should move the mean close to the target and then you reduce the variation. If you reduce the variation, CP will become 1.67. If you move the mean close to target, CPK will also become 1.67. All right? All of you understand?
Yes.
So now tell me, what is the purpose of CP? CP tells whether the process variation is higher or lower. Am I correct? Yes or no?
Yes, sir.
Yes, sir. Yeah.
Yeah, CP tells whether the process variation is higher or lower. We want low variation, right? So that is why, the action required is reduce variation. But how to reduce variation? You have to make adjustment in the process, study the process, improve the process, it will go down. Similarly, CPK is giving us an information that process is off-centered. Process is off-centered. It's not on the target. So we are moving the process mean towards the target. Now, data being used in the initial setup of a process are assumed to have a normal distribution. Data is normally distributed, bell-shaped. If the target is set at the center in the distribution, exactly the center and target are same. That means no shifting of the process. All of you, do you understand the meaning is the process is on the target, no shifting. If process is not shifted, TP will be equal to CPK. Please understand. If process is not shifted, CP will be equal to CPK. Now, specification limits are set at plus or minus 3 sigma. What is the name of the point which are at 3 sigma from the center? What is the name of the point which are at 3 sigma distance from the center?
Control limits.
Control limits.
But now they are telling you specification limits are also at the same point. Specification limits are set at plus or minus 3 sigma. Now control limit overlap with the specification limit. When control limit overlap with the specification limit, what is the sigma level of the process? Is it 3 sigma or 6 sigma or something else?
3 sigmas.
3 sigma. All of you, do you understand? You must have been taught, isn't it? On day 1 or day 2? Day 2. It's an elephant process.
Yes.
Control limit will stretch and touch the specification limit. When the control limit and specification limits are same and the process is centered perfectly on the target, then CPK will be equal to 1. CPK equal to 1, right? So 3 sigma process means you divide by whatever the sigma level, when you divide by 3, that will get you the CPK actually, right? So in whatever way you remember, here the CPK is 1.
Yeah.
All of you are able to understand what is how CPK is 1 here.
Yes.
What is the formula for CPK? CPK is half of the specification width divided by half of the process width,
Yeah.
right?
Yes.
And in this case, both are 3 sigma only, because specification is also at the 3 sigma distance. Control limit is also at 3 sigma distance. 3 sigma by 3 sigma is 1.
1.
So answer is 1.
Hmm.
Clear?
Yes.
Now, significance level in a sampling study is fixed as 1%. What will be the confidence level of this study? Level of significance is fixed as 1%. General practice is 5%. But in a particular study, because the study is very critical, the process is critical, so the company wanted to keep a very low significance level. Level of significance is 1%. Now, what is the confidence level? All of you, do you know the relationship between level of significance and confidence level? Yes or no? What is level of significance? Alpha, am I right? Alpha error. Alpha error is type 1 error. I think this week only you all learned it. Am I right?
Yes, yes.
I only have taught you. Type 1 error. The maximum permissible type 1 error is known as level of significance. In a particular study, it is 1% only allowed. So what is the confidence level the company is expecting?
1 minus alpha.
1 minus alpha, which is 99%. 1 means 100 minus 1%, which is 99%. Suppose if the level of significance is 5%, what will be the confidence level? Come on, you are expected to respond.
95%.
95%. Suppose if the level of significance is 10%, what will
90.
happen? 9%. Once alpha is known, confidence level is also known.
No.
Because when you sum them up, when you sum both of them, it will definitely equal to 100%. Clear?
Yes.
Yes.
Now read through this question and you have to pick up the correct hypothesis testing. A company, ABC company, want to know whether the proportion of customers who return a survey increases by providing an incentive such as a promotional discount coupon. If you complete my survey, I'll give you a coupon code using which you can purchase products at a very discounted price, right? So survey is expected to increase by providing the incentive, right? Such as a promotional discount coupon on completion of the survey. The percentage response with the coupon is to be compared against percentage response without coupon. Now, which hypothesis testing it is? First of all, please answer my question. Percentage response, is it statistically called average or proportion?
Percentage, proportion.
Proportions.
Yeah, percentage response is nothing but proportion. 100 people filling the survey. 100 people I am requesting. When I tell them that you also have an incentive, then many people will do the survey, isn't it? So all of you have given the review in Google review for the training you have undergone. We have shared it, right? Shared the link.
Yes.
Yeah,
Yes, sir.
please fill up, and you do have an incentive, right? Please do it in the Google page. You can write a review. So the percentage response with coupon is to be compared with the response without coupon. So it is proportion. A proportion of one group is compared against another group. Now, what is this hypothesis testing?
Two proportion.
Proportions.
That's all. Very good. Now, for a particular task, the assumption is turnaround time is a function of region. The regions are, FR, DE, UK, maybe France, Denmark, UK, something like that. So you have 3 areas, and which office, which area where you have the office is having a better turnaround time. That is what you are trying to understand. Now, what is the hypothesis testing you should go for now? There are 3 groups you are studying, right?
ANOVA, sir.
ANOVA.
So it is
Specific-
continuous data or discrete, sir?
It-
3
yeah.
region
it-
means
Turnaround time.
It-
Turnaround time
Continue.
is a
okay.
measurable
It's
data.
a continuous.
Very good, very good. Like Navneet is
It's
saying,
a-
it is continuous, measurable. Time is measurable.
Okay.
And you are comparing more than 2 groups in one go. More than 2 groups in one go. It is ANOVA. It is specifically called one-way ANOVA. Why it is called one-way ANOVA? You are just having one factor. You are just having one factor. What is the factor? The region is the factor. Is it your turnaround time depends on the region or not? Do you get my point? Whether the turnaround time really depends on the region. Because you have your process is same, you are only checking whether all your 3 offices have the same turnaround time. If not, you will try to find out why it is so. All right.
So if we are combining these 3 regions, it will go to proportion test, J-square test. Then discrete data.
No. Come again. What are you saying?
If we comparing these 3 region, now we are comparing turnaround time. That's why it's continuous data. If we comparing this 3 region, then it will become discrete data.
No.
Ah.
See, discrete data means your data is countable. Right? So even if you are combining, you need to know why are you combining and all those things. Ultimately, what are you measuring? You are measuring turnaround time. Turnaround time. Time is measurable in any case.
Yes, sir.
Time is measurable. And you have three groups. You are measuring the time for France, measuring the time for Denmark, you are measuring the time for UK, and ultimately you are comparing. Let's say it is 10 minutes for France and 12 minutes for Denmark, and 14 minits for UK. And probably
Clssgb test will come on the proportion that countable data.
see, if your data is continuous data for more than two groups, it is ANOVA only.
Okay.
If you want to conduct chi-square test, you must have some information which you can measure as proportion. Time, we don't generally express in terms of proportion. Time, 10 minutes, 10 times. So what is the average time? That is what we look at, isn't it? The average turnaround time for the first group is compared against average turnaround time for the second group. Suppose if it is percentage rejection, or suppose if it is pass percentage of the students of the green belt 34th batch, 35th batch, and 36th batch. What is pass percentage? Pass percentage is proportion. Right? So like a survey, how many people are responding to a survey? That is pass, that is proportion. But here it is continuous data. So it is ANOVA. And since you are studying about only one factor, what is that factor? The region is the factor. Whether there is a variation with respect to the region. The factor is region. So it is, since there is only one factor, it is also known as one-way ANOVA. You can call it ANOVA, or actually it is one-way ANOVA. If there are two factors you study at a time, then it is two-way ANOVA, which you will be learning on day number 5, two-way ANOVA also. Now, a department want to migrate to a new tool which claims to reduce the cycle time for a particular process. What would be the correct null hypothesis? I think we discussed this in the class, right? Null hypothesis, alternate hypothesis. What is null?
ठीक है, इसके बारे में और फिर डिस्कस करेंगे.
Come again, come Yadav. You are on mute.
Hello.
Yes,
Actually,
Yadav.
I have joined late too, because
No
just
problem.
I have
No
just
problem,
I
no
have come
problem.
from
You can.
office. So okay, I think sir, it's just about the how exam will be conducted.
Yeah, that is what we are discussing about the question, right?
Okay.
So what kind of questions you can expect in the exam? We are just exploring similar questions.
So it is an overview of examination that will be
Yes,
conducted.
yes,
Okay,
exactly.
okay, no problem. Okay, thanks.
All right. So if you can do these kind of questions, and you are going to do very well in the exam. That's all. That is the point. Now, hypothesis testing, which is a null hypothesis in this case. What is your understanding about null hypothesis? Come on, please speak out. What is your understanding about null hypothesis? Is it statement of innocence?
Statement of equality.
Very good. It is statement of equality. And now tell me, do you see any equality in the 4 options? You see equality in option C and D. Am I right? Yes,
Yes,
sir.
sir.
Yes, sir.
But why C is not correct? I have highlighted only D. Because the symbol, generally we use the symbol H0 for null hypothesis, isn't it? That is the reason. Right? Though it is silly, but actually this is making D the best answer. All of you understand?
But sir, if we process this one, the output will be it's the alternate hypothesis only will be cyclic time of the process with the new tool not equal to cyclic time of the process with the old tool only we will get.
See, that depends on data. I have not given you the data.
But in question that alternate hypothesis was reduce the cycle time for a particular process. Then the cycle time with the new tool less than the cyclic time with the old tool is the alternate hypothesis.
Correct. You are correct.
Then the null hypothesis is its opposite. It's greater than.
Yes. No, not opposite. When you say greater than also, when you say less than also, in both case it is null only. Sorry, in both case it is alternate only.
Alternate only.
Null means equality should come. Null means equality should come, right? So if there is no equality equal to symbol participating in your statement, then it is alternate only. Though we say it is opposite, you have to make it equal.
But sir, with this null hypothesis, we will get a p-value if there is a data. Data is given.
Okay.
Then the conclusion will be it is p-value is less than 0.05. We can reject the null hypothesis.
Yes, you reject. Correct. You please reject.
Then if we reject that null hypothesis, the alternate hypothesis will be cyclic time process is not equal to cyclic time.
Accepted. Practically, you are correct. I really appreciate. But what is the question here? Now this is exam. Yeah,
Yes,
this is the quiz program. You just have to answer to the situation. Now, what is the situation? What would be the correct null hypothesis? Question is not what is correct alternate hypothesis. Question is what is correct null hypothesis. You have only either C or D. And I already told you the problem with C is symbol. But D is perfect. So I suggest you to go with the option D. Option D is the best answer here. But whatever statement you made, James, it's correct. Right? But now this is...
I think it is a B. B is a cyclic time process with the neutral is greater than cyclic time process with the altitude. If we take this as the null hypothesis, then only we will get the first sentence of the question.
No. Actually, your understanding is wrong. You should never write null hypothesis in that manner. If at all you wanted to use this, you must say greater than or equal to. You must say greater than or equal to. Then the less than will be alternate.
Yes, sir.
Right?
Yes.
So without equal to sign, if you are making a statement, it is alternate only. So this is like, rule of the game. You have to live with it.
Okay.
If it is cricket, you have to play with 11 players only. You should not say, I have the 12th player also ready, so I will have him inside. No, he will not be allowed. Right? So this is a rule of the hypothesis testing. Always we start with null, and the null should be statement of equality. Right? Good points to understand. Now this one. Which test will you conduct to compare variance of more than two groups? You know the hypothesis testing for mean. You know the hypothesis testing for proportion. Similarly, there are hypothesis testing for variance. If there are only two groups, you compare the variance. It is called F test. It is called F test. More than two groups, it is called Bartlett test. And chi-square test is for proportion. ANOVA test is for average. All of you agree? ANOVA is for average. Chi-square is for proportion. The A and B are for variance. Variances are equal for two groups. That's the null for F test. Right? Variances are unequal. Between three groups or any number of more than two groups. Now it is Bartlett test. Clear? So that is the answer. Okay. Now here, a hospital wants to determine whether there is any difference in the average turnaround time of report. You are giving a blood sample and the hospital laboratory is doing the, some lab testing, and ultimately the report is printed and the particular medical officer is signing, and then the signed report finally comes to you. The total time consumed is the CTQ here, turnaround time. And now you have 4 laboratory. Which laboratory is, giving you the report faster, which means the turnaround time is lesser, right? So is there any specific laboratory? All the 4 laboratory are operated by the same hospital. But now I want to know whether any laboratory is so fast or any laboratory is, so late. I just wanted to find out. And now what is the test called? What is this test called? Turnaround time is continuous data or discrete data?
Continuous data.
Continuous data, and we are comparing 4 groups, then we'll go for ANOVA.
ANOVA. Again, it is one-way ANOVA. The output is turnaround time. The factor is 4 laboratories. Laboratory 1, laboratory 2, laboratory 3, laboratory 4. There are 4 laboratories. The factor is laboratory. Number of levels, 4 levels. Lab 1, lab 2, lab 3, lab 4. This is called one-way ANOVA. At 5% level of significance, you just have to figure out whether there is a significance in the study. A study is considered to have significance, so the report becomes significant. Please understand. The study is considered to be significant. So what happened? The report also becomes significant. If the report becomes significant, you can use the report and you can draw conclusion. You can do all these things only when the p-value is less than 0.05. Only when the p-value is less than 0.05. Conduct the ANOVA. The report will come with the p-value. If the p-value is less than 0.05, you can say there is significant difference. If p-value is more than 0.05, you have to say there is no significant difference. If there is no significant difference, will you still conclude that there is a difference? Don't conclude. Data will always have difference. Am I correct?
Yes.
Suppose, if all of you write the exam, obviously there will be a difference in the mark. Let us say Navneet scored, 80 mark and our Agilan scored 81 mark. Now can you see a difference between 80 and 81? Is there a difference or not?
Yes, sir.
1 mark extra Agilan scored. Does it mean, Agilan has understood more than Navneet? Or does it mean the knowledge in our level of Agilan is more than Navneet because he got 1 extra mark?
No.
I'm doubtful because the difference is very small. Whenever the difference is small, we don't consider the difference as a difference in real life. When the difference is small, we don't consider the difference as a difference in real life. A difference is considered a difference in real life if it is significant. So what is the boundary line for significance? In a test mark, please tell me, what could be a significant difference? A difference of 1 mark is not significant. Suppose if Navneet mark is 80 and Agilan mark is 90, will you accept the significance? Yes or no?
Yes.
So there is a boundary. The boundary depends on real-time scenario. But for all scenario, without even knowing the boundary, you can take the correct decision by using the tool called p-value. By using the tool called p-value. Because p-value is generated based on your data. Based on your data. Your data will be converted into an intermediate statistics. Your data will be converted into an intermediate statistics. And the intermediate statistics will be converted into p-value. For example, test mark is converted into average test mark. Test mark will be converted into average test mark. In the example I am talking, turnaround time. Turnaround time will be converted into average turnaround time. All of you are with me?
Yes,
Now for each of the turnaround time, I convert that into another score. Another score. Sometimes we call it G score. Sometimes we call it F score. As far as the ANOVA is concerned, we will be using a distribution called F distribution. We will be using a distribution called F distribution. F distribution is a distribution of variance in the data. And the F score will be generated. F score will be generated using the data. F score will be converted into p-value. So how all this happens? Minitab is taking care. Ultimately, you look at the p-value. Ultimately, you look at the p-value. If the p-value is less than 0.05, the difference is significant. don't ignore your report. Don't ignore your report. In all the other situations, you must ignore the report. Though you have conducted the study, don't conclude anything using the study. That is the meaning of insignificance. Simply continue with your innocence. What is your innocence? All the laboratories are performing at the same level. Continue with it. All of you understand what I'm telling? Yes. Now what is written here? Option D. There is significant difference, which means what could be the p-value? What could be the p-value then?
Greater than.
It is saying significance. If it is saying significance, what could be the p-value? Greater than 0.05 or less than 0.05?
Greater than.
I think all you have to again go through our recording.
No,
on
no,
the topic.
actually, sir, if significant, then we can say that p-value is less than 0.05 now.
Yes, that is correct. So if you
Yeah.
actually conduct the study for yourself for this particular problem, you will get a p-value of less than 0.05. If time permits, I'll show it in the Minitab. But now the correct answer is significant difference. I'll show it. So this problem, data will be provided. And then using the data, you have to generate p-value by conducting ANOVA. And if the p-value is less than 0.05, go with option D. If the p-value is more than 0.05, can you tell me the answer? If p-value is more than 0.05, yes.
Yeah, there
Very
is a
good.
B,
Option B is
B
the correct
option.
answer. B option is
Okay.
correct. Very good. Now correlation. The closer the correlation coefficient, all of you know correlation coefficient is small r.
Hmm.
If
Yeah,
it is equal to 1, the relationship is perfect. If it is
Okay.
closer to 1, the relationship is stronger.
Stronger.
If it is less than 0.7 and above 0.4, it is moderate. Less than 0.4, it is weak. This is our understanding. Now, the closer the correlation coefficient is to plus or minus 1, then what is the nature of relationship? Is it stronger? Is it moderate or weaker or dubious?
Stronger.
Stronger.
Because it is close to 1, right? Close to 1 is stronger. If it is 1, what will you say? If it is 1, what will you say? Perfect. If it is 1, you should say perfect, a straight line. If it is 0.5, what will you say?
0.5 moderate.
Moderate. If it is 0.3, what will you say? Weaker.
Weaker.
Up to 0.4, weaker. 0.4 to 0.7, moderate.
Moderate.
More than 0.7, strong. Equal to 1, perfect.
Perfect.
If it is positive, strong positive. If it is negative, strong negative. Right? So the option is here, the best option is stronger. The coefficient of correlation between U and V and the relationship is U equal to X, V equal to minus X. U equal to X, V equal to minus X. Now, what is the coefficient of correlation? See here, U equal to X. Let us say X equal to 1. So, V equal to minus 1. Am I right? Which means U equal to minus V. U equal to minus V. Now, what is the coefficient of correlation? Coefficient is this
Minus.
area.
-1. Okay.
Minus 1. That's all. Right? When we, so the constant is the
Excuse me, sir. Suppose V is equal to minus X upon 2, then we can say that the correlation coefficient is minus 0.5.
1 minute,
Am I okay?
1 minute. V equal to
V equal to minus X upon 2. Then we can say that correlation coefficient is minus 0.5.
very good, correct.
Yeah. Okay. Thank you.
All right. Fine. So we move on. The relationship between number of beers consumed, right, and the alcohol level in the blood was studied in 16 male candidates by using the least square method. The following regression equation is obtained. Y equal to minus 0.0127 plus 0.0180x. What is the meaning of this regression model? So what is Y here? What is Y here? Is it the
Minus.
number of beers or the amount of alcohol? Which is X and which is Y?
Blood alcohol content is Y.
Blood alcohol content is Y. And the number of beers consumed is X.
X.
More you consume, more will be the alcohol level in your blood, right? And so X and Y is understood. Now, which statement is holding good? Every single beer you consume, your blood alcohol will increase by 1.8%. The 1.8% is derived from regression coefficient. Can you see that? The 1.8% is derived from regression coefficient. And the X is the beers consumed, right? Like, number of beers. And Y is the alcohol level. So every unit increase in the X will lead to certain percentage increase in the Y. That percentage is explained by the respective regression coefficient. Hope all of you understand the meaning of regression coefficient.
Okay.
1.0180. You multiply by 100, you get 1.8%. Right? So this is what I wanted to explain to all of you. If you have understood everything I have explained today, and I think the green belt level exam will be easy to crack. But over and above, you have to be strong with the theory part also. So all that are number related discussion we had, right?
Yeah.
Non-number discussion, which company introduced Six Sigma? Is it Ford or is it Toyota or is it
Motorola.
Right. So these kind of questions you all very familiar, right? And the green belt, black belt, and all those things. See, we have discussed almost everything. Almost everything we have discussed. So you should be able to answer all the questions. If you are missing a question, it is purely it's not by chance. It is purely because you have not put some effort. So you still have a lot of time. Today is Wednesday, right? Thursday, Friday. And Saturday only the examination for the green belts, not for the black belts, right? Only for the green belts. You can expect the examination link to come to your email ID by 4 p.m. Right?
Sir, Excel files send on chat window only or on WhatsApp?
WhatsApp group. In WhatsApp group, I have already shared.
Excel file. That this calculation Excel files by
Yes,
RK
yes.
and all. Okay.
No. I have shared right now only one file. RK sir has given you many Excel file. I do not know how many of you have followed him and you have understood how to use the file. That is also a good approach. Please understand that. Now I have simplified everything, given only one file.
Okay.
One Excel file. One Excel file will handle everything, right?
Okay.
And it's up to you. Anyway, the final landing point is same. You will get the same answer. But this is easier. So I'm giving you, you can use this. And if you are comfortable with the already shared template, that also you can use it. All right.
Okay.
So that's it from me about your, the discussion on exam question. And maybe we still have 2 more minutes. I can try to show you the turnaround time problem in Minitab, right? If you like it. Or otherwise, if there are any other questions, you can ask me, right? And once we do with that the p-value question, the turnaround time for the laboratory, we are done with the session, right?
Okay.
And writing the exam, I think it's easy task. And
Sir, any case this p-value will come exact 0.05?
Exactly 0.05. Yeah.
Any problem will come. I don't know. That's it. If something come, what we can take. If not come.
Okay. Very good question. Yeah. And condition, what is the condition? P-value should be, come on, tell me what is the condition? P-value should be less than 0.05, right?
0.05. Then it
If
is
it is
significant.
0.5, tell me, is it less than 0.05 or more than 0.05 or equal to, see, equal to 0.05 is definitely not less than 0.05.
Okay.
That's all. That's there. There is your answer, right?
Okay.
All right. So let me see whether I can get that question, that particular case, and we'll see that and then close the day. Close the session. Batch 21, exercise 5, statistic A3, exercise 5. Turnaround time. Lab tat. I got it luckily. Okay, I got it. It is opening. So I'll only show that in mini tab, and then you come to know the p-value. So as far as the lab turnaround time, the hypothesis testing is, what is the name of the hypothesis testing? What is that? Come on.
ANOVA.
ANOVA. And specifically, one-way ANOVA. Right? One-way means we are considering only one factor. For example, we are giving you conducting the exam and certification is done only based on your mark. Am I right? Nothing else. Then it is one-way ANOVA because your test mark is also a measurable data. Yeah. Please confirm. Can you see my Minitab screen? All of you?
Yes, sir.
Yeah.
Yes, sir.
Laboratory 1, laboratory 2, 3, and 4. Okay. Lab 1, lab 2, lab 3, lab 4. And then a lot of data available. Equal number of data under each category. I think 100 or more than that. Okay. 120 data available. So now we should go to ANOVA. Go to stat. Go to ANOVA. Then where should I go?
One way.
One-way ANOVA. Now this will come. Response data are in one column. No, I don't have data in one column. I have data in separate columns. Column 1, column 2, column 3, column 4. Now come and click in the response. Now where is the response? C1, C2, C3, C4. Select all of them. Select. Now go to options. Assume equal variance. Whenever you are doing ANOVA, the assumption is equal variance. If it is an untick, you have to tick it. And then confidence level 95%. When I say confidence level 95%, what is the level of significance?
5%.
5%. Always
5%.
they are interlinked. So it is 5%. Now it is two-sided. Give OK. Again you give OK. Now ANOVA is performed. You can see the average turnaround time for laboratory 1 is here. Laboratory 2 is here. Laboratory 3 is here. Laboratory 4 is here. For every average, confidence limits are also indicated. Can you see upper confidence limit, lower confidence limit? Upper confidence limit, lower confidence limit, upper limit, lower limit, upper limit, lower limit. If you compare 1 and 2, this upper limit and this upper limit, there is a overlapping. Can you see that? If I keep one over the other, there is a clear overlapping. Do you understand the meaning of overlapping? If I bring this eye and keep it on this eye, exactly I move it horizontally, you can see both eyes crossing each other. Am I right or not? See, can you see two different eyes? I am bringing one over the other. Now both are overlapping. That means there is no significant difference. But when I bring the fourth eye, do you think it is overlapping with any of the other laboratory?
No,
No.
sir.
Even up to the 95% limit, even the limit is not overlapping. Similarly, for laboratory 3 also, I can move it. Clearly, which laboratory is taking more time? Which laboratory is taking more time?
3, laboratory 3.
Laboratory 3. Which laboratory is taking less time?
Laboratory 4.
Laboratory 4. So the difference is significant. Why do I say significant? Because no, the lower limit of the laboratory 3 is above the upper limit of any other laboratory. The lower limit itself is above all the laboratory. Even if everything goes well for laboratory number 4, laboratory number 3, they will prepare the report here only. Do you understand the meaning of bottom line? Lower confidence limit means even if everything is going well, their turnaround time will be this value. What is the lower value? It is saying, can you read it out, one of you? A small number. 197. At the earliest, you can expect report from laboratory 3 after 197 minutes. All of you, do you understand the meaning? If everything goes wrong, then the same laboratory will take 202 minutes. Do you understand the meaning now, all of you? Yes or no? Yes, right?
Yes, sir.
So this 197 is clearly above all the other values in the graph. That is why with 95% confidence, I am telling that laboratory 3 takes a longer turnaround time. And laboratory 4 takes the shorter turnaround time. I can make a conclusion now. Why am I making a conclusion? Even if sometimes things can go wrong, sometimes things can go well. Even in that situation, my conclusion will hold good. All of you, do you understand the meaning of what I'm talking? Clear?
Yes.
This
That's
is only for if any variation, we need to correct that variation. So that only we are conducting these types of tests, right?
Yeah. See, variation will be there. Variation, certain amount of variation will be there. That is why the average is fluctuating. Even if the average is fluctuating to a great extent, then also my conclusion will not go wrong. That is my point. I am telling you, all of you will pass the exam. Because what is the lower limit? 60 mark. Only if you go below 60, you will fail. Do you understand? 95%, with 95% confidence, I am telling you that you all will score between 60 and 100. Because 60 is the pass mark. You understand?
Yeah.
Provided you have gone through the process. Suppose if you have violated the process, you may go outside the confidence limit. That's a different story. But now the normal story is mark will be between 60 to 100. So this is ANOVA. That is the reason why we have concluded the difference is significant. You can see a lower p-value in the report. Look here in the statistical report in the session window. Can you see the p-value for the factor? How much is the p-value?
0.00.
0.0000. After some number will come, but Minitab is not giving us. It cannot be perfectly 0. There will be some number. So less than 0.05. So the study is significant. Why the study is significant? There is the error. The type 1 error I can expect is less than 5%. The type 1 error, if at all there is an error, I am sure it will be less than 5%. That is confirmed by p-value. When the error is less, I will take decision using the data. When the error is more than 5%, I will better don't take risk of making a conclusion. All of you, do you understand how do we use the p-value? Let me write it for you. P-value is less than 5%. Is this statement correct? Yes or no?
Yes.
Now p-value means estimated type 1 error. This will happen only when you reject null. When you reject the null, this will happen. The estimated type 1 error when rejecting a null is less than 5%. That is the meaning. All of you understand? When the estimated type 1 error is less than 5%, When estimated type 1 error is less than 5%, my confidence level is
95.
more than 95%.
Yes.
Sorry. Confidence level is more than 95%.
Hmm.
What is my actually confidence level? Confidence level is, see, the type 1 error as well as confidence level, all of them are related to null hypothesis only. All of them are related to null hypothesis only. Now, in this case, what is our conclusion? Since p-value is less than 5%, my conclusion is, what is the conclusion? Please tell me.
Reject null hypothesis.
Very good. Reject the null. Now you are not committing an error of more than 5%. You are not committing an error of more than 5%. You are within the permissible level only. How much is permissible? 5% is permissible. That is the rule of the game.
Sir, here, which is what is the null hypothesis given?
Null hypothesis. The null is turnaround time of all 4 labs are equal. That's all. Mathematically, turnaround time of laboratory 1 is equal to turnaround time of laboratory 2, which is equal to turnaround time of laboratory 3, which is equal to turnaround time of laboratory 4. So
We
TAT
have
1
to,
equal to
we
TAT
have
2.
to given in settings also this one. Settings while giving that calculation, we have to given the settings there. One selection is there. Select the null hypothesis.
See here, yeah, correct. See here, it is written on the top one. Null hypothesis, what is written?
All are equal.
All are equal. Alternate is at least one is different.
Okay.
Significance level is 5%.
Okay.
Because we have selected confidence level 95%, which means significance level is 5%. So this is how it works. And now the p-value is less than 0.05. So the study is significant. Hope it is understood by all of you.
Significance level means it is error. 5% of error is accepted means we have to promise our customer to send 95% of goods as good.
Yes. See here. Now that we are teaching you the 6 Sigma green belt body of knowledge, black belt body of knowledge, and the different tools we are teaching you. Am I right?
Yes, sir.
Right. With all
Yes,
our good faith, we think that whatever we teach is correct. Am I right?
Right.
But
Right.
still, we might have misunderstood something, isn't it? And
Yes,
we may
it
pass
may
the
be
same,
happen.
and we may pass the same thing to you. If at all that is happening, for a good training program, it should be less than 5%.
Sure.
Same way.
Sure.
Same
Without
way.
error, no process is perfect. Everything
Possibilities are
could
there.
not perfect in the world.
Right?
Yes.
You say
Yes.
there are no
So
errors.
we need to. Yes. So that only we need to set the error percentage is 5%.
Yes. Always, there will be some error. If there is no error, then
Definitely.
you are full of perfection. Then you are someone like God.
Definitely.
Right? So that is
Definitely.
impossible.
Definitely.
So that is why
Definitely.
always certain percentage is allotted for the error, type 1 error and type 2 error. Anything will happen. So that is what we are measuring, we are estimating. That this is also an estimation. Please, all of you understand. This is only an estimation. Still, you may be wrong in your conclusion. But the chance for you to go wrong is limited to 5%. Right? Though you are deciding with the data, still the reality can be different. Sometimes it happens. You might have done everything.
This is just like Nostradamus predictions, right?
Yes. Exactly.
He was already predicted those things. We are going to conclude whether the things are happened or not. Now we are checking in our generation, in future generation. Up to 2050, he has predicted what are all the things going to happen in the world.
Correct. So based on
Nostradamus predictions
certain data, he has predicted. Similarly, based on the data, now you have predicted. Right? It can happen, it can be exactly same or it can be different. But in your case, You are confident to the extent of 95%. Only 5% chance is there. And that 5% chance is also due to the variation in the data. Suppose now,
Similar to
suppose
Nostradamus prediction also.
imagine I am conducting
So-
5 examinations, 5 exam.
Okay.
All 5 exam, you are scoring exactly 25 marks. Now have you passed? Now what should I declare? Have you should I declare you as pass or fail? All 5 times you score only 25 marks only out of 100. Now what should I do? Should I declare you as pass or fail?
Fail.
Fail only.
Absolutely no variation. Now I have more confidence in saying that you have failed, isn't it? So the lesser the variation, more will be the confidence. Similarly, all 5 times I conduct 5 exam, the mock exam. In all mock exam, you are scoring 90, 90, 90, 90. I have given the mock exam, isn't it? Hope all of you have seen the link, right? In all the mock exam, you are scoring 90. And now I am predicting that you will score above 90 in the final exam. It can happen. It can happen, isn't it? And the variation in your mark will reflect in the final exam. Maybe you may score above 90. Maybe you must score 88. Isn't it? Why this is happening? Because there is a variation. But if all your exam performance are exactly 90, then statistically my prediction will also be 90 only. That's all. Because everything is same, no variation. So I will expect, the straight line is 90. When I extend the line, extended line also will show 90 only. If the line is going upward, then the extended line will give some other prediction, isn't it? So something like that. It is based on the past data. We are predicting the future, which is called inferential in statistics. The variation in your data will bring down your confidence level, right? Will bring down your confidence level. And moreover, the confidence level also depends on the difference you are trying to validate. If the difference is too high, then even with a higher variation, even with a lower sample size, even with a lower number of data, you can still gain the confidence level. But if the difference is too low, like the example I said between Agilan and our who is the other person, our Navneet, 80 mark and 81 mark, the difference is just 1. And in order to say the 1 mark is significant, I should at least conduct several exams several times. In all occasions, the difference should be exactly 1. If that is happening, then only then I may agree. Okay, yes, definitely Agilan is little better than Navneet, because in all 10 exams he scored 1 mark extra. So which is which cannot happen without one is actually talented. So I think the session has brought some clarity to all of you, particularly from the examination point of view, right? So wish you all the very best, and I'm sure you all will do well in the exam. Please pass on the knowledge and share the knowledge with your co-participants, so that everybody.
In which date, sir, in which date you have scheduled examination for black belt?
Saturday, coming Saturday.
Yeah, coming Saturday.
Coming Saturday is the first option, appearance for all the green belts. All the green belts must take the exam this Saturday, anytime after 4 p.m. till midnight. All that required is 90 minutes with laptop, Excel file, Minitab, internet connectivity. Even if Minitab is not there, as far as the exam is concerned, not much will require Minitab. But Minitab, if you have, it will be advantageous, right? So 90 minutes with the proper internet connectivity this Saturday, first appearance. Those of you who are not able to write, you have any special reasons, better try to avoid. Write it Saturday only. If there is any problem, you will be getting one more chance. You will be getting one more chance, but at the maximum, only 2 chances. So the first chance is compulsory. First chance is compulsory.
Is also applicable for this, sir.
Come again?
Black belt also applicable for this examination, no?
See, actually, this Saturday.